Recording in progress. All right. Okay, so hello everyone. I'm Stefanos Baziotis. I'm a fourth-year PhD student at the Computer Science Department of UIUC. Today, I'm very glad to be joined by William J. Rapaport, a philosopher and computer scientist. He got his PhD in philosophy from Indiana University in 1976. Oh, by the way, William, you should interrupt me if I say anything wrong.
No, I will, but please call me Bill.
Oh, okay. Bill. All right. So Bill got his PhD in philosophy from Indiana University in 1976, his master's in computer science from sunny Buffalo in 1984. He is an associate professor in the Department of Computer Science and Engineering, an affiliated faculty member in the Department of Philosophy and of Linguistics, and a member of the Center for Cognitive Sciences, all at the State University of New York at Buffalo. Now, William is an AI expert who has been leading pioneering work in the field of philosophy of computer science. In particular, he has written the book, Philosophy of Computer Science, An Introduction to the Issues and the Literature. In my opinion, it's a seminal piece of work, one of the few authoritative sources on the subject, and it is what introduced me to William. I definitely commend it not only as an introduction to philosophy of computer science, but also, I should say, as an introduction to philosophy in general, especially if you're a computer scientist or a programmer. And also, William's writing is one of the best, so don't be intimidated by the terms like philosophy and literature. This is neither an obscure text nor a dry listing of literature. Now, today our discussion will revolve around this book, but also around two recent papers that William published. One is Will AI Succeed? The yes position. You may hear me refer to this as the AI debate paper. And the second is Large Language Models and the Turing Test, subtitled The Use of Words versus General Educated Opinion, which I may refer to as...
Just one caveat there. So neither paper has been published yet.
Well, I should say I meant they're available, publicly available for people to read them. But
that they are, and comments are welcome because they're not published.
Great. Okay. So just to be sure, you mean they're not published in a journal or conference, right?
Right. So the large language models paper has been submitted to a journal, and the AI debate paper, I don't know if it will ever see the light of day because it was originally intended as a chapter in a debate book.
Right.
This fellow at Rensselaer Polytech named Selma Bringsjord. He's also a philosopher / computer scientist. And we would write this debate book where I would say, yes, AI will succeed. And he was going to say, no, it won't. But he's never written his chapter. Or if he has, he hasn't shown it to me yet. So
okay.
I'm just waiting on that one.
Well, thing is, they're both publicly available for people to read and comment. I should say everything is going to be down in the video description, all references, as well as all references to things that we're going to mention during the discussion. Well, at least anything I can find. Now, before officially, I guess, welcoming William, I'd like to inform the audience about my project for this discussion. So generally, I do not want, and I will probably actively avoid repeating things from these sources. So, for example, if you expect kind of a summary or an introduction, I'm afraid you may be disappointed. That the goal here is to kind of create original content, which I think will also create more value for the viewers, and hopefully it will make it more enjoyable for you, William. So to that end, I will assume, anyway, this is not live, that the audience is already somewhat familiar with the content, and what we can try doing here is expand on it, question, interpret it, explain it, and we can also use it as a starting point for further discussions. Last but not least, we get a bunch of questions from the audience, I want to say, and I will also shoot these questions. They were too many, unfortunately, to ask all of them. So thank you, everyone, for the participation. And they were also, most of them were pretty good. So honestly, I chose sort of randomly. Okay, so with that, welcome, William. Thank you very much for being here. I'm very excited.
I'm happy to be here.
Great. Okay, so maybe we can start a little bit with like light stuff. you can tell us maybe a little bit about your trajectory. So you've had a very interesting trajectory where you've sort of been through or in both computer science and philosophy departments. So maybe you can tell us a little bit about that, and maybe also how people can approach a career, an academic career that involves both.
All right, so I started out as a philosopher. I was teaching philosophy at Fredonia State College in New York. It's a 4-year undergraduate institution. And I was working in the area of philosophy of mind and philosophy of language,
Okay.
both of which are relevant to artificial intelligence, because the point of AI is to try to create a computational mind and one that can talk to you. So philosophy of mind, philosophy of language are kind of central to AI. And I had come across a book by a British philosopher slash computer scientist named Aaron Sloman called The Computer Revolution in Philosophy. It was written in the late 70s, I believe.
Okay.
And one of the points he made in the book was that if you were a philosopher working in mind and language and didn't know anything about AI, that was a little bit like a philosopher of physics not knowing anything about quantum mechanics.
Okay.
That sounded
Yeah, makes sense.
plausible to me. So I decided to take a year off and work on study AIs. I studied computer science. I sat in on some computer science, computer programming courses at Fredonia.
Just to be sure, sorry to interrupt, just to be sure, we're talking here circa
This is let's say 1981,
okay.
81.
Okay.
So Fredonia is near Buffalo. A fellow that I had known in computer science at Buffalo at Indiana, had just moved to Buffalo. He was working in AI. So I joined the Buffalo department as a graduate student. I was a tenured associate professor of philosophy at Fredonia, but I was a first-year graduate student in computer
Okay.
science at Buffalo. And we clicked. It turned out that the kind of AI he was doing, what is now called symbolic AI or good old-fashioned AI, not neural network AI. He was working in areas of logic and language understanding that mirrored the work I had been doing in philosophy of language and philosophy of mind perfectly. He had developed a semantic network processing system that was supposed to sort of represent the mind of a computational agent. And he had just published a paper with another graduate student, actually a graduate student who has a PhD in psychology,
Okay.
on an idiosyncrasy in language having to do with how you represent yourself, sort of a self-concept. And he made what I would consider a mistake. He didn't realize a certain subtlety in language. I say he, I should say they, the two of them. But it was something that my major professor in philosophy had worked on. And so I said, well, here's what you really need to do. You really need to represent things in this way. I'm being very vague in general. We can go into it in detail if you want, but I want to give you the background history.
Yep.
That turned out to be my master's thesis in computer science.
Ah, I see. Okay.
Correcting this little error, so to speak, in their representation scheme. When I was done, they offered me a job.
Okay.
And it was one of those offers you can't refuse. I mean, moving from a 4-year undergraduate college to a major research institution in a bigger city, it was exactly what I wanted. So I did that and became a professor of computer science. They had also begun this Center for Cognitive Science. So cognitive science is kind of an interdisciplinary study of the mind where people from all kinds of different disciplines who are interested in the mind, linguistics, psychology, philosophy, computer science, anthropology, In our university at UB, we also have people from the English department, from the geography department, from the speech and hearing department, who would just all get together and talk about things and share information. And they were working on a research project on understanding narrative. How would you get a computational agent to read a story and be able to keep track of who the characters are, where they are, when things are happening, and so on. So the people from English literature were excited about this. The people from psychology were studying these things. The people from linguistics were certainly interested. And I kind of wore the philosophy hat, and we had the computer system to kind of build the model of this reader. So that was my trajectory. And the way philosophy of computer science came into it, around 2005, I decided I wanted to teach a seminar. I thought, well, philosophy of computer science might be something interesting. It turned out there were almost no courses anywhere in philosophy of computer science. There were essentially no textbooks.
Yep.
So I had to kind of create the course from scratch, which I did. It was a successful course. And I decided, well, since there were no textbooks, let me start writing one. And then
I believe that was when the first edition came out, around 2006.
So I wrote a paper that got published, I think around 2005, 2006, just describing the course that I taught.
Okay.
In 2012, I retired.
Okay.
And my retirement project was to write the textbook. Which took me about 10 years. So the book came out in 2023.
Okay, so I had wrong information.
Okay.
So I was reading, I think it was somewhere in the links, somewhere through the links on your webpage. I ended up upon a thing that was basically just plain text, and it was talking about the first edition. But I probably misinterpreted that. Okay, so the edition that came out, I believe the 2023 edition of the book was the first edition of the book.
That was, yeah.
Okay. Wow, interesting.
I mean, it circulated on the internet as an unpublished manuscript for several years. That may be what you're thinking of.
Well, that's that. So I thought, so that's a different thing. No, that was something that I had a discussion with someone on Reddit when I was talking about our discussion, and that person told me that they had read a manuscript of your work. So I imagine that was
that may be
around...
what they had seen. Yeah.
Yeah. Okay.
I took that down once the book got published, but you can still find it if you dig deep enough. It's longer. It's about twice as long as the published version.
Oh wow.
Which is what most of the thing I had to do when it was accepted for publication. I had to cut it in half. So.
Okay, makes sense. Interesting trajectory, I guess. So it seems a very, so to speak, special trajectory in that it seems, well, I guess, I don't know, correct me if I'm wrong, but every time you have people that are interdisciplinary, it's usually sort of special. Like it's not necessarily something that you can take, like it's not really a set path. It's someone else who wants to work on computer science and philosophy can say, oh, yeah, okay, this is how it works. Like I first get my PhD here and my master's there and I'm good. Yeah, but which is nice. I mean,
I think the thing with interdisciplinary work is either finding somebody else in some other discipline who is working on exactly the same problem you are, but looking at it from a different perspective. So then the two of you can kind of get together and really do something interdisciplinary. Or people from two or more disciplines looking for a project that they can each contribute to from their own perspectives. So the work that I did for my master's thesis on belief representation was a problem that somebody else was working on that I had also worked on.
Okay.
Narrative understanding project was a topic where several of us wanted to do something together and settled on that as an interesting project. And then
I
other
see.
people got interested in it and joined us.
I think what you're saying totally makes sense. It even agrees with my little experience. So I'm doing sort of coming from compilers and databases. Lately, I've been combining that with, I'm coming from compilers and program languages. Lately, I've been combining that with databases. And it really was, I mean, I don't think anything would have gotten published if it wasn't for Daniel, who's a database person, and then Charith, my main advisor, he's a compilers person, and sort of that kind of works together. Yeah.
I mean, look, that's interdisciplinary too. It's still all within computer science,
Yes. Yeah.
but it's from
Yeah.
two very different branches of computer science.
Definitely.
And that, in a sense, also makes it a kind of interdisciplinary approach.
Yeah. Yeah. Okay, so I guess before starting going deep, I would like to hear your opinion on formal education in philosophy. Now, I have to say here, I don't have much of that. Okay, so I'm now officially taking my first course in philosophy this semester, but from my sort of little experience here, to me it seems more like an education in history of philosophy, maybe I would say it, which is sort of who did what when, I would call it. Like
What course are you taking?
Well, I should not say this is not true for the course I'm taking.
Okay.
So the course I'm taking is ethics in AI.
Okay.
So Zach, the professor, if you're watching this, you're good. Okay. But I would say most of like other courses that I've experienced, I would like not to mention them. So it seems like more things like what were the main arguments, counter arguments, and I call it history of philosophy because it seems to be concerned more with events, whereas my understanding of education in philosophy is more, it's not passive in that way, it's more active. It's like learning to think in a certain way. And so I would like your opinion on that, whether you think that's true, especially because your book doesn't seem to be that at all. It's, I mean, in a way, the book raises more questions, like it makes the reader question things than like learning events more than anything. And
But
I
look,
guess,
if you're taking a history of philosophy course, yeah, it's going to be, you know, this philosopher said this in this year, and this other philosopher said you're wrong, and here's what I think in this later year, and so on.
yes,
If you're taking a problems-oriented course, say a philosophy of language course or an ethics in AI course, you're going to be looking at certain issues, certain problems, certain questions. You know, should we build ethical machines? Can machines be ethical? What are the ethics of using AI and so on? Or if you're doing philosophy of language, you'd be interested in questions of semantics and syntax and meaning and so on.
hmm
To study those problems in philosophy, um, you usually want to see what other people have said about the issue.
right,
Hopefully, you will disagree with them about the issue, or maybe you'll agree but want to extend their viewpoint in some way. And so you're arguing in the good sense of arguing, right?
yeah, yeah,
Not having a fight, but you know, debating issues.
yeah, yeah,
If it's a classic problem, yeah, you might want to go back and look at what Socrates might have said about ethical issues and see if anything that he said might be applicable to the issues in AI. They might not be, and you might decide, you know, he's completely irrelevant. So I think part of what you might be getting at is a question concerned with the notion of whether there is ever any progress in philosophy. Because look, when you study computer science or physics or any science, you don't study the history, right? Nobody in a physics class is going to say, well, we'll start by reading Isaac Newton and we'll work our way up through, Einstein, and then we'll get to Fermi and so on. You just study what has been concluded or decided, what the current theories are. Philosophy is not quite like that. Some people say because philosophy never makes any progress. That's debatable. But it's also because you can still find interesting and important and useful things that older philosophers have said that can be relevant.
Right. Yeah. I agree. Just to say here, I do think there's progress in philosophy. It may be maybe where I'm getting at is it may be true, and I guess you can enlighten us here that philosophy in the active sense may be very difficult may not admit structured learning. And this may
Define
be
what you mean by structured learning.
well, okay, yeah, that's a good question. But I mean, if you have a history of philosophy kind of approach, like who did what when, right?
Right.
What were the main arguments, right? Then it's very easy to create a midterm, for example, or sort of easy, I guess, right? Whereas in the active kind of thing, like, okay, how can you think on problems? I think it's much harder to create a midterm and like grade it fairly among students and things like that, because you're not judging whether someone remembers something or has a certain knowledge of something. It's whether they can actively think, and that feels to me much harder. I mean, of course, I'm not an instructor, right? So it may not be harder for you, let's say.
Well, let's see. There are a couple of things to say about that. So first of all, in terms of what you're calling structured learning, I think that the way to study philosophy is almost exactly the same as the way to study anything. So I started out in mathematics. My undergraduate degree was in math, and I did some graduate work in math. And the way, I shouldn't say the way, because mathematicians may get upset with me because I didn't pursue any math beyond master's level courses. But one way to study mathematics is you have to read everything slowly. You have to think about every statement that is made in a textbook or in a proof. You have to make sure you understand it before you go on, because you really can't go on to the next step if you don't have a firm grasp of the steps that preceded it in the argument.
Right.
So when I moved from mathematics to philosophy, from undergraduate to graduate, I didn't know how to study philosophy, but I did know how to study mathematics. And I thought, okay, I'll study philosophy the same way. I will read each sentence in some famous philosopher's essay and make sure I understand it before I go on to the next one. And it worked. I mean, one advantage is when you get to something you don't understand, you need to ask a question. Why don't I understand this? Was there some step that I missed? Or maybe there was a step that the philosopher missed that I've just discovered because I was thinking about it maybe in a slightly different way from the philosopher, but now I'm reading it slowly and carefully, and I see a path that didn't get taken. So I think really it's this, one should study philosophy, or one can study philosophy the same way one can study any science. Slowly, step by step, make sure you understand everything before going on to the next step.
Yep.
As for how you create exams in philosophy and how you grade them, that's a whole different topic.
Okay.
So what I'm going to recommend for you to look at, so I told you that the publisher made me cut out half of my book before he would publish it, right?
Mm-hmm.
Well, the other half is online. If you go to the book, it tells you where you can find link to the online resources.
Okay.
part of the online resources is kind of an instructor's manual.
Okay, yeah.
And in that instructor's manual, I talk about strategies for writing philosophy exams. So rather than delve into that right now, unless you want to, what I'll suggest is go take a look at that.
No, that's very good. I will. I mean, I've actually taken a look at the online resources, but not in the instructor's manual.
Okay, go take a look at that. The other aspect is grading, and it turns out I've written about that too. So one of my philosophy professors at Indiana, a fellow named Paul Spade, years after I graduated, I ran into him at a conference, and he made a comment about how he and every other faculty member I've ever met hate grading essays. I mean, there's a lot to read, and if they're undergraduate essays, most of them are not going to be very good, and you still got to read them and so on. And he said he decided that really there were only three kinds of essays or answers to questions, that the students would write. There were the ones that the student basically got it right. They understood the issue, they've explained it well, they've argued well. Yeah, one could criticize it, but basically they've got it. They know what they're doing. There are also the ones who clearly do not know what they're doing. They've completely misunderstood. They can't write. It's just obviously bad.
Yeah.
And then there's everything in between. And the basic idea is it's not worth trying to distinguish the in-between into finer gradations. And so I developed what I call a triage theory of grading.
Okay.
Any exam, essay, whatever, can be graded on a 3-point basis. Full credit if, they basically got it right. They made a little mistake here or there, but they basically understood. 0 credit if they just completely screwed up. You don't want to fail them because they at least wrote the essay rather than dropping out of class. You give them 1 point instead of 3 points, and 0 points with a person who didn't even do the assignment.
Yeah.
And then everybody else gets a 2. So you only have 3 grades: 1, 2, and 3. Call them D, C, and A if you want, right? And the advantage is you don't have to worry about making fine distinctions. The student can say, can I get 1 extra point on this for partial credit? And I can say no, because you're in that vast in between. You're not perfect. I can't make you perfect by giving you 1 extra point.
Okay.
And students tend to like it because it's easier for them to understand the grade. Why did I get B- and this guy got a C+? The distinctions aren't that fine. Of course, you do have to, the instructor has to give feedback. I mean, you can't just give the paper back and say, well, this is neither perfect nor imperfect, but I won't tell you why. You got to give some comments back. So that's my take on grading.
That's cool. Yeah, I hadn't heard of that. That's interesting. Thank you. All right, so I'd like now to start going a little bit deeper into the topics of the book.
Okay.
So I'm going to start with a quote. Generally, I like starting from quotes, especially, well, one is plagiarism goes away because it's clear where I got the idea. But second, I try to choose quotes that have multiple ways you can view them, and so you can choose the way you want to view them. So here I would like to talk about Aristotle on Τέχνη versus Епιστήμη, which very simply we could translate them for now, I guess, okay, Episteme is knowledge or scientific knowledge for Aristotle, and Tέχνη is art or craft, even today, actually, in modern Greek. And so Aristotle says the object of Episteme exists of necessity, which I will interpret as like that which could not be otherwise. Example, laws of math. And for Tέχνη, he says, on the other hand, we can say, is concerned with something which may or may not exist, and of which the moving principle is in the producer, not in the thing being produced. So a painting, for example. So I guess to summarize, episteme is concerned with that which could not be otherwise, whereas Tέχνη is concerned with that which could be otherwise. I have a clarification here with like what Aristotle meant by episteme, which is not quite what we think of today, but I don't think it matters that much. I think even if we take episteme to mean what we understand today as science, I guess the distinction still seems relevant. And if that's so, computer science seems more of a technique than an episteme because, for example, operating systems could definitely be otherwise, right? And the reason that they are the way they are is in the producer, like in the designer who made them that way. And then before giving it to you, if we accept that CS is a technique, then it seems that that implies that it makes mainly inventions and not discoveries. So what is your take on that?
Right. So I'm not an Aristotle scholar, so I'm not going to try to say what Aristotle might have meant by that.
Yeah, no, it's just, again, I use it like kind of as a starting point.
Sure. I mean, the way you describe it, it sounds to me more like the distinction between later philosophers who were called the rationalists versus the empiricists. So the rationalists were people like Descartes, who basically thought that the only things that were certain were things like mathematics. The things that we perceive might be mistaken. And the empiricists, people like Locke, Berkeley, and Hume, who thought that most knowledge came from experience with the world, empirical knowledge. I mean, that sounds a little bit like the techne-episteme distinction, the way you're making it. Where does computer science fit in? Well, I think that's related to the question of whether computer science is a branch of science or whether it's a branch of engineering. So I don't know about Illinois, but at Buffalo, computer science used to be in the Faculty of Natural Sciences.
Okay. I don't think we even have that. But it is part of the College of Engineering, although it's a really complicated
we moved into the College of Engineering. What happened was they merged. So there was a computer science department, and there was a computer engineering. Sorry, it was an engineering and computer. What are they? I even remember what they called electrical engineering and computer department. Okay. Electrical and computer engineering. That was it. It was called electrical and computer engineering. And a new dean came in, or a new provost came in and rearranged everything. They took all of the computer engineers out of the electrical and computer engineering department and merged them with the computer science people. So we became the Department of Computer Science and Engineering.
Okay.
ECE became just EE, electrical engineering. They weren't very happy about that. And all of a sudden, our department became twice as big, and there were all these engineers who, most of us computer scientists, were, who are you guys? We're not engineers, we're scientists. So what I find
that's hilarious.
So in my book, I talk about this issue.
I know, yeah.
And I kind of straddle the fence. I don't think you can say that computer science is nothing but science, nor do I think you can say it's nothing but a kind of engineering. There are certainly branches of computer science which are purely mathematical. Think theory of computation, right? And there are clearly branches of computer science. Think anybody who's building a computer, which is clearly more on the engineering side of things.
Yep.
Right. And then there are people who work in programming languages. Well, I mean, there's an aspect of programming language theory which is very theoretical and mathematical. But you also have to implement those languages, and that becomes a kind of engineering problem.
Yep.
So I mean, I think computer science straddles both of those fences. There was one administrator we had who thought that the computer science department would eventually disappear because all the theoreticians would wind up in the math department, the people doing AI would wind up in philosophy and psychology, the computer engineers would go back to the engineering department, and so on. There was nothing that was really computer science, right? We all did different things. And this harps back to the discussion we had earlier about interdisciplinary. So in a philosophy department, every philosophy faculty member is expected to be able to teach any course in the philosophy department. And when you go to graduate school, you've got to study all the branches of philosophy. I mean, this will vary from school to school, but basically that's true. But in computer science, I mean, the theoreticians really couldn't speak to the programming language people, who really couldn't speak to the database people, who really couldn't speak to the people working in AI. They were different disciplines, which is why we were talking about databases plus, programming languages is interdisciplinary in a small way. Whether that's good or bad, whether that's true of every department or other, is a matter of fact. But I mean, basically, I think computer science straddles the fence. And at the end of my book, where I try to give a one-sentence definition of computer science, I call it a scientific discipline, where scientific is meant to include engineering, because engineering is clearly scientific. There's this wonderful acronym STEM, right? Science, technology, engineering, and mathematics, which is designed to cover that whole realm of things, which is neither techne nor episteme, but a little bit of both. By the way, just a little footnote. The first acronym was SMET, Science, Mathematics, Engineering, and Technology. I wrote a grant proposal for a SMET grant. Fortunately, they decided to rename it STEM.
It's funny how language works, right? I mean, SMET is not a word, but somehow it sounds weirder than STEM.
Right. Well, it sounds like smut. So.
Okay. Okay. All right. I guess. Well, just I don't know. I feel like I'd like to press just a little bit on this discovery versus invention thing. Sorry. I just want to say that you also, if I remember correctly, you also give a definition that kind of diffuses this antagonism between engineering and computers and science and all these things in the AI debate paper, where you also clarify why you're doing it so that you don't have this thing. But I would like to press a little bit on discovery versus invention by asking maybe a more specific question, if it admits kind of a simple response. Do you think that quicksort is a discovery or an invention?
Yeah, it is. So look, this is a classic problem in the philosophy of mathematics. Are theorems in mathematics discovered or are they invented? And it partly depends on what you think the subject matter is. Is the subject matter something that's out there that exists independently of human minds, in which case you're discovering things? Or is it purely a product of the mind, in which case you're inventing something? And there, in terms of mathematics, mathematicians who are sometimes called Platonists believe that numbers exist independently of the mind. What we are doing is discovering mathematical laws, mathematical theorems. Proving them is clearly something you invent. You invent a proof, although somebody might say, well, the proof was always out there, you've just discovered it. And other people, so those are called Platonists in mathematics. Other mathematicians are called intuitionists, and they claim that mathematics is just a product of the mind, of intuition in a kind of Germanic sense of the term. I think the same is true for your example, quicksort. Yeah, somebody probably, whoever it was, I don't remember who it was who invented quicksort.
I unfortunately don't remember right now either.
Right. I mean, there's the difference between sciences and philosophy, right? We don't care who invented it or discovered it. It's there. We can just use it. Insofar as quicksort is a mathematical notion, then Platonists would say, well, it was always out there and somebody discovered it. So it really depends on whether you think these things exist independently of us. So one way to think about that issue, I'm not going to resolve anything here, is suppose we meet extraterrestrials, right? Presumably everything about them is going to be different.
Mm-hmm.
But the general assumption is mathematics will be the same. And if you believe that, then we're discovering mathematics, not inventing it.
Yeah.
But maybe their mathematics is going to be so different from ours that there is a certain amount of invention involved, because it depends on the way their minds work.
I think that makes sense. Yeah, I agree. I mean, there's also this whole kind of anyway, I think it is probably a digression, right? But like we can also probably think in terms of Kant and synthetic a priori, right? That maybe that's part of like how we see the world. And an extraterrestrial
Right.
would have a different synthetic a priori, seeing the world differently.
Right. Absolutely. Absolutely. I mean, look, I don't know if you saw the movie, and I'm blocking on the name. Was it Alien or Contact? It was a recent movie where these aliens come to Earth and they hire a linguist to try to talk to them. It's based on a wonderful short story that I would urge you to read. And of course, right now I can't think of what it is, and this is full screen, so I can't even check my computer.
Yeah.
But yeah, I mean, if you view the world entirely differently, if you view time, the nature of time differently, than trying to talk about time in English versus extraterrestrial language is going to be really, really difficult to do the translation.
Yeah, that makes sense. Okay, so I would like maybe kind of the couple generic questions before we move to the papers. So here, I would like to go into the notion of like what is an algorithm, and specifically whether a neural network is an instance of an algorithm. Now, I know. So here's the thing. I think that probably you would imply that it is, given what my reading of your book when you talk about System 1 and System 2, and B, what you talk about in the AI debate paper. But because from reading the book, it seems that you, and I like that, you don't like to give people answers, but rather you like them to question things. And what you seem to be very good at in the book, and what you seem to like, is to sort of examine other people's thoughts. So here's what I'm gonna, instead of asking you to answer whether neural network is an instance of an algorithm, I would like to give you a statement by another computer scientist and maybe examine it. So this is from Iosif Sifakis. He's a Turing Award winner. He said, an algorithm is a procedure written by a programmer. So it's a procedure that we can read and verify. What brings about the success of AI is not algorithms, but neural networks, which are not programmed, but trained. Here, there's a big difference because we don't understand how neural networks work.
Yeah, I mean, I agree with all of that. But what I would want to say is that underlying neural network programs is an algorithm that tells the neural network how to be trained. That's not a very precise way of putting it, but somebody has written an algorithm that says, this is how we're going to train neural networks. We'll use backpropagation. We'll do this. We'll do that. And yes, the neural network is doing something, quote unquote, on its own during the training, but there's an underlying algorithm which is doing the training. So,
but does that mean that, oh, sorry, go ahead.
No, go ahead.
I guess the question is, does that mean that, like, if we know the process that produces something, does that mean that the product, like if the process is an algorithm, does that mean that the product also is algorithmic?
It can be, but I think it doesn't have to be. And yes, right. I mean, so that would be one way of putting it. It might be the case that the actual training, the way the neural network settles on its quote unquote understanding of whatever's going on, how it chooses the next word, right? In a large language model, which is Noam Chomsky called it just a super autocomplete system. How it decides on what the next word is going to be. We may not know why it chooses it, but the algorithm that told it how to make that choice was an algorithm.
Yes.
There was a program there that said you're going to use backpropagation or transformations or whatever I don't do neural networks, so I'm not familiar with all the lingo. There's an algorithm underlying that, even though the thing that is produced might be a device that we don't really understand how it is making the decisions.
Well, I guess maybe a follow-up question here. I don't have it here, but it's just what comes to mind is, let's just say that I have a program which generates random programs, right? Like literally, it just puts random bytes.
Okay.
And then I take that program and I run it over the spec benchmark or any benchmark. Basically, I treat the result as a compiler. And that, I mean, obviously the space is intractable, but let's say I'm lucky and like after some time I just stumble upon, it's totally random, right? I have no idea. I mean, it's a very, very random algorithm. It's very simple. Just puts byte, and after some time I stumble upon a program randomly, which I run over the spec benchmark and I get improvement. And I produce correct code, blah blah. But like, how did it help me that I know the algorithm that produced it? I mean, the algorithm that produced it is very simple, and it really gives me no understanding whatsoever into what the program does.
Right. And that's the situation with neural networks.
Yes.
Right? Except the underlying algorithm isn't simple.
Yes.
But there is an underlying algorithm, and the output of that algorithm is this neural network that examines data in the world and tries to categorize it. But
Right. I'm just saying sorry.
How it's choosing what to look at and why it categorizes things the way it does, we don't really fully understand because we're not privy to its internal workings.
Yeah, makes sense.
I mean, look, so good old-fashioned AI was an attempt to really implement cognitive aspects of things purely algorithmically. So they would actually, you want to talk about representing somebody's beliefs, there would be a node in a network that represents a belief. It's right there. We can see it. And we can see what other nodes it's connected to, and so on. Neural networks don't work that way. I forgot exactly where I was going with this, but Oh, I know where I was going with it. So look, there are two ways of creating, there are at least two ways of creating an intelligent entity, right? One way, when I started out in AI, it was this good old-fashioned symbolic way. The other way is having a baby, right? Now, we really don't know how babies' minds work. We have all kinds of theories, but there's a lot of stuff we really don't know how the human brain works. What we're doing with neural networks is closer to having a baby than it is to creating good old-fashioned symbolic AI programs, because what we're producing, we don't really understand how it works.
I like the analogy. I love the analogy. Okay, I'll move past. I really just want to ask some questions on the papers themselves.
Okay.
So now I'm going to move to the AI debate paper, and here maybe you can enlighten us a little bit about the how we evaluate AI success, which was it was a little bit confusing to me, and I think I'm missing something, right? So let me just sort of summarize my understanding of the statements made in the paper, okay? So I think this is focusing on section 3.2, although I guess doesn't matter.
I don't
Okay,
have the
so
paper in front of me, so it doesn't matter.
yeah. Okay, so on the one hand, your evaluation of success seems to be behavioral, at least in this section. Well, asterisk, unless we take the evaluation of success, the change of language which you're talking about, which is not really what I mean here. So if we take that out, but if you want to put that at the epicenter, please do so. But if we take that out, it seems that your evaluation of success seems to be behavioral. So some variation of the Turing test. Then, on the other hand, different parts of the paper seem to imply that AI success rests on understanding cognition. So, for example, you have a statement here for people who are watching this. It's in 4.2.2. You say, the AI project is different from just understanding human cognition. It is to understand cognition more generally, which seems to be an even loftier goal. And then in other parts still, so that's the third, you say that the project is to investigate whether cognition is computable. So maybe we can first start with restating how we evaluate AI success and whether it does or it does not require an understanding of cognition.
All right. So let's start with the Turing test. So first of all, there really is no such thing as the Turing test.
Yes.
I prefer to talk about Turing tests in the plural or Turing-like tests. But my point there, I think I would express it now as saying that what we want to judge in an AI system is, I don't want to use the word behavior. I'll say it's the output of the system. I want to avoid the word behavior because behaviorism as a strategy in psychology is everybody hates it these days. It's very controversial. So I prefer just saying let's look at the output of the system. Mm-hmm. And I think that's basically what the idea behind a Turing-like test is. Mm-hmm. You run the program, you interact with it in some way, and typically that interaction is going to be linguistic, though maybe that's too narrow a way of looking at it. And that's really all you can go
on. Right.
Now, when I talk about cognition more generally than just human cognition, psychologists are primarily interested in human cognition. How is it that we think? And we are the only ones who we're absolutely positive can think. I mean, it's only been fairly recently, within the last maybe 50 years, that people have said, yeah, a lot of animals can think, and maybe more animals think than we used to thought. But there might be other kinds of thinking too. The thinking of extraterrestrials, the thinking of large language models. Maybe we don't want to say they think, but they sure seem, some of them sure seem like they do, right? So I'm more interested in cognition more generally. If I can produce an AI program that convinces you that it is quote unquote intelligent, but it doesn't behave in any way, shape, or form like a human does, that's fine by me, right? I'm not interested in how humans think, except maybe as a guide to how to get a computer to think. I'm interested in thinking in a much more general, abstract sense. So, for example, I mean, or not for example, but another aspect of this is a lot of people want to say, look, large language models don't think, because thinking is something only living things can do, like human beings.
Yeah.
And I want to say that's unfair. Sure, in some sense, only birds and bees and bats can fly. Airplanes don't, but nobody talks that way anymore, right?
Yeah.
Airplanes are just as good flying devices as the animal kingdom. And we, in fact, have a much more general theory of what it means to fly than just flapping wings. In fact, airplanes don't flap wings, but the shape of the wing of an airplane, as I understand it, is relevantly similar to the shape of wings on birds and so on. So there were aspects that make a more general theory of flying. And this
A unified theory of flying.
I'm sorry?
A unified theory of flying.
Exactly. So this is why I like that phrase of that passage from Turing about the use of words in general educated opinion will change.
Yeah.
The use of the word fly and the use of the word computer have changed. Or the original use of the word computer referred only to a human being, typically a woman, who did computations. Originally, flying was only something that birds, bats, and bees did. Nowadays, computer means a physical device. In fact, it sounds odd to talk about a human as being a computer.
Yeah.
But there's a more general theory of what computation is that both human computers and Mac laptops seem to be doing.
Mm-hmm.
There's a more general notion of flying that both birds and airplanes seem to be doing.
Yep. Makes sense. I totally makes sense. And I really like the
And so,
analogy with
so I'm sorry, the end of
yeah.
that is ditto for thinking or cognition. Humans think, humans have cognition, but I want to broaden that to include possibly computers, extraterrestrials, what have you.
Right. And that totally makes sense. But so I guess my question here was, when it comes to AI success, does that require an understanding of cognition? So in the three, I guess, how should I call that? Dimensions? I don't know. When we're talking about AI's success, you could say that, look, AI will succeed when you produce something that convinces us that it has cognition. And that's sort of like, okay, judging from the output, right? But that doesn't mean that we have an understanding of cognition.
Right. I agree.
Right?
Yes. I
Right.
agree.
So, but then again, in the in the other passage, you say the AI projects is different from just understanding human cognition, which seems to assume that the
No,
AI project
the
is
emphasis
about.
on the word human there. The AI project is different from just understanding
Oh, okay.
human cognition.
Okay. Okay.
Okay.
Okay. Yeah.
Um,
Okay.
so I don't think we need a full understanding, whatever that might mean, of cognition before we can start to build AI computers. But I think that as we build them, we are going to simultaneously refine our understanding of what cognition is.
Okay.
So let's talk about large language models like ChatGPT, right? A lot of people think that LLMs think and understand language. And a lot of computer scientists and people working in AI say, no, they don't, not yet, right? All they're doing is super autocomplete. But why do those people, I call them in my LLM paper, incredulous judges.
Right.
Why are they skeptical? Because there are aspects of cognition that large language models don't yet exhibit.
Mm-hmm.
They make silly mistakes, they do hallucinations, they can't really plan very well. I mean, there's a whole list of things. And in that large language model paper, I have a whole list of about 20 things that they don't yet do.
Yeah.
That I think they have to before we can really fully say, yeah, they're thinking at the level of human thinking, at least at the level of human thinking.
Right. But it's about exhibiting, right?
Yes.
Okay.
Yeah.
Uh,
So
yeah.
all right. So there's one other feature there, and that is what has to be in the algorithms or in the training or in the neural network or whatever that is going to give us all of those things, right?
That's more about understanding.
That's part of the understanding. Can we get it all just from the methods that are used in large language models? Well, a lot of people, Gary Marcus in particular, say, no, it's not going to just be a question of scaling up, getting better training, getting more data to train on, and so on. There's got to be something else. There's got to be maybe a GoFi, good old-fashioned AI component to the algorithms that can actually reason, that can use logic, that isn't just kind of getting its logic from observing somebody else doing it and figuring out what might be the case. But we won't know that until we can get better algorithms to do this. And that will give us a better understanding of what's needed for cognition.
That makes sense. I think something that I have later is relevant. Let me think. I'm not going to move there now. Just if we can sort of quickly answer kind of a last thing on this, which is, do you think that giving evidence that something is computable requires understanding it?
Um, as I said just now, I don't think you necessarily have to have a full understanding of it. Your understanding will grow with developing the algorithm.
Yeah.
That may not be the case for some simple things, like do you have to have a full understanding of what it means to sort a list before you can discover or invent quicksort to do it more efficiently? And there, yeah, the answer is yes. I mean, if you only have a vague notion of what it means to sort things, you're not going to be able to get very far. You may have to decide if you're sorting words or sentences alphabetically or in some way, you're going to sort on the word the or on the word that follows the. You're going to sort, on some things you might not want to use as the key for sorting. Those are arbitrary decisions, basically. And once you realize that the vague notion of sorting has to be made more precise, then yes, you have a better understanding, and then you can sit down and write quicksort or invent quicksort. Cognition is a much vaguer thing, right? Understanding, thinking, reasoning, speaking, planning, these are all basically vague notions that you have to make somewhat precise before you can begin to write algorithms for them. But as you're writing the algorithms and you see that the output isn't what you want, then you've realized that you need a better understanding of what it is you're trying to model computationally. And then you can refine your algorithm. So it's going to be going back and forth. It's not just I'll have a firm understanding, then I'll write my computer program. You have a fairly firm understanding, you write a computer program, you see that it doesn't do quite what you expected it to do, and you suddenly realize where you were vague. So you start to make things a little bit more precise and code it up. That's why in the computational view of mind, why cognitive science liked computers so much was it forced them to be precise about these vague notions that were all part of the notion of cognition. You have to be precise in a computer program. Even if you're writing a neural network, the underlying algorithm that is the training of the neural network has got to be very precise. And if the neural network's training is saying, yes, I think this cat is a dog, there's something wrong in the way it's been trained, and you got to rewrite it.
I think that makes sense. And that's exactly why in my last question, and I guess in the third thing I said earlier, I focused on computable. And just because maybe someone will say, look, maybe to produce cognition in general, I don't need to really understand cognition. But to give evidence that it's computable, I need to understand it. But I think what you're saying, which is it's sort of a back and forth, totally makes sense.
Yeah.
So the next question, I'm going to move then to the LLM paper. Next question, though, is, okay, so a warning, it's really phrased a little bit adversarially. I didn't mean it that way. It's just, I really didn't know how to phrase it more nicely.
One thing I learned as a philosopher to have a very thick skin. One of the first talks I gave, so my PhD dissertation was on a philosopher named Alexius Meinong, fairly obscure. And when I started working with him, every major philosopher said Meinong was, forget him, he was just stupid. Meinong thought that everything existed, even things that don't exist.
Okay.
And I gave a talk at Ohio State University. I don't remember if it was a job. It wasn't a job talk. It was just a talk. And during the question session, by the way, can I curse on this video? Is anybody gonna?
I don't care. Yeah, I think it's fine.
The very first question I got was, "What the fuck are you mucking around with this Meinong shit for?" Everybody laughed. I laughed. I explained why I thought Meinong was interesting and important. He said, "Good. I like your answer." Don't worry about adversarial questions.
Oh my God, you remind me an anecdote. Oh my God, okay, I should not say who told me that, but anyway, I had given a talk and it was a little bit I guess I got some hard questions. Now looking back at it, it was, totally fine, but it's I was a little bit like after that, I was just kind of sad. It had gotten into me, so to speak. And then there was someone, a professor from, well, I'll just say that professor, he had experiences from MIT. And he told me, oh, come on, you thought that was like, he was like, at MIT, people come to give talks, and then the audience starts fighting with each other to the point that like the speaker is not even our, it's not even our focus anymore.
Yep, I've seen that happen. Yep. Yep.
Okay, so here's the question. So you say very nicely, how do you prove that something is not computable? Not by failing to find a program for it. And I totally agree, right? But also to prove that something is computable, you have to find a program for it. Now, of course, the point of this paper is not to prove that cognition is computable, but to argue that there's no logical reason to believe it isn't.
Right.
Now, before Gödel, the world of mathematics was very optimistic. And I'm not sure that back then there was a logical reason not to believe that we could prove everything that was true. So what I'm getting at with this is, do you think that this discussion is really a discussion like whether you should be an optimist or a pessimist? And in that sense, maybe it's immaterial right now.
I think my view is let's see, I'm a pessimistic optimist, or maybe an optimistic pessimist. I'm optimistic about the eventual success of AI.
Mm-hmm.
I'm a pessimist about it happening now. I don't think LLMs are fully intelligent because of the long list of things that they cannot yet do that I cite in my paper. But I don't see any reason to think that most of those things won't eventually be accomplished. It may not be solely by some fancy neural network. It may need some kind of GoFi, component that'll do the reasoning or the symbolic manipulation, and it may require some new techniques that we haven't got yet. We just can't think of right now. So look, it seems to me that there are two ways to show that something is not computable. Right? One way is to prove logically, as with the halting problem, that it's assuming that it is computable leads to a contradiction. Right?
Yeah.
I have not seen any argument of that form for AI. One reason probably that there cannot even be such an argument of that form is that the goal, namely cognition, is kind of vague. And until we can make it more precise, you're not going to be able to get that kind of a logical proof. So the only other kind of proof is one that says roughly, and this is a caricature, but cognition is too complicated. So there's this book by Barry Smith and Jörg Landgrabe. Why I forget the title of it.
Yeah, but it's interesting because I have here their names because it's part of a question, but I don't have the book. Yeah.
Okay, so I mean their claim is basically that no currently known mathematics is such that it will give us cognition. There's no current mathematical theory that we can write an algorithm for that will give us human-like cognition.
Mm-hmm.
Well, I agree. There is no currently known mathematical theory that has given us a computable theory of cognition. But that doesn't mean that there might not be in the future. And it may never happen. And it may never happen for uninteresting reasons like all the funding dries up or an asteroid hits Earth and we just never get there because it will really take 1,000 years and the asteroid hits us in year 999. those are uninteresting practical reasons why AI might not succeed. To say it's just too complicated is to give up. It's to say it's not worth doing the research. I think it is worth doing the research. And I think it's an ongoing issue. I don't think we're ever going to get to the point where we say we've solved the problem, except possibly in the sense that Turing said that eventually we'll just start saying, yeah, it thinks we're just going to change our language so that, we've solved it. Because our language is going to change. It's inevitable.
Yeah. Okay. All right. So with that, I'd like to move to the LLM paper. So I'd like to introduce this paper. As I said, we assume that people are familiar with that. But I think this is cool because I'd like to introduce it by answering a question from the audience. And you should correct me if I'm wrong. So Evangelos Lambrou, he's asking, given the rapid deployment of LLMs in critical domains, for example, legal, medical, and scientific research, do you think that there's an urgent need to redefine what we consider understanding in AI? If so, how should we approach this redefinition? And my answer to this, Evangelos, is this is exactly what this paper deals with, along with many other things. So do you agree with that?
Well, first of all, I would take issue with the idea that there is active deployment of these things. I think a lot of people are using them, but I don't think they're being used in any serious way. I mean, there's the famous story of the lawyer who had an LLM write a legal brief for him, and it gave all kinds of citations to non-existent legal documents, right? There's controversy in its use in medical diagnosis. There are people who say, yeah, it can pass all medical exams, but I still wouldn't trust it for with a real patient. I think the attitude we have to take right now with the current state of LLMs is to be very, very cautious and not to take them at face value. You have to be skeptical with their output. Their output can be very impressive in certain very constrained circumstances. But in certain other not so constrained circumstances, they may sound like they're playing a good game, but you got to treat it with a grain of salt. You got to be a little bit skeptical. So, for example, I'm not very happy with the fact that the very first search result in Google now comes from an LLM.
Oh my God, I'm also not happy with that. And I recently read an article of how a lot of other people are not. And so it's interesting that now a lot of people are moving their searches to Reddit. Because in Reddit, people ask questions, and there's someone who's like, for example, even the other day, I was on Reddit, and someone was like, "Hey, I'm just looking to translate this thing in Greece, blah blah blah." And someone was like, "Hi, I'm a professional translator. This is where you go to do it." So sorry for an interruption.
No, I mean, look, there's an actor named David Alan Grier, and I was curious about him, so I Googled him. And I said, David Alan Grier is a comedian and an associate professor of political science at George Washington University. Wow, that's impressive. So I looked him up on Wikipedia, and no, he's just a comedian. But there is a David Alan Grier who's a professor of political science at GWU. Maybe I got the department wrong. Maybe I got the university.
Yeah.
And then I went back to Google and I saw in the fine print, AI generated response, right? And following that, I tried to ignore that first response on Google and go down to the actual search results. Typically, the first one will be one of the primary sources that the AI generated one got its information from. Well, why go to the intermediary
Yes.
of the LLM? Why not go directly to the source? Exactly the same as with your Reddit example. So I think the major lesson that we're learning is people have to learn to be critical of the output of these LLM-based computers and not trust them not be fully trusting of them. But look, how
That
do you
makes sense.
trust somebody? You listen to what they say and you try to verify it at some point. And if most of what they say gets verified, you can begin to trust it. That doesn't mean that at some point they may say something that isn't right.
Yeah.
You still have to be that's one of the reasons I start my philosophy of computer science textbook with lessons on how to be critical, how to analyze something, how to decide whether somebody's telling you something that sounds right. I don't want to say telling you the truth, but something that seems reasonable.
That was, I want to say to people, I actually had a question on that. I skipped it, but I do want to say to people that the theories of truth that you present in the book were some of the things that it was something that I had not really encountered before, and I really do urge people to take a look at that. So regarding what you're saying, that really, I mean, maybe here well, let's see. Can I quote the paper is the question. Well, but exactly what you're saying that, here you say, many commentators have pointed to the alleged dangers of artificial general intelligence and the singularity, but there's a more serious, because more pressing problem, our current willingness to credulously accept Turing test passing entities as intelligent, which is exactly what you have been describing. And so, given that, I would like to ask you, so here's a prediction, okay, or I don't know, a hypothesis. So intelligence in general is faulty, at least our intelligence, right? I mean, I'm not sure about super intelligence. So human calculators, one reason they were replaced, in my understanding, is to get absolutely reliable results. I mean, of course, performance and speed was a very important factor too, but it seems that correctness, reliability, robustness, things like that were important. And a dumb digital calculator is much more reliable than an intelligent human calculator. So, given that, do you think that even if we get to artificial general intelligence, we'll figure out to have to have any kind of robustness, we should go back to interpretable methods, precise algorithms, precise formal language semantics, and formal methods? And I'm calling this the full circle prediction because for me, I mean, this is kind of the reason I got into computing. That's what I think computing have always been about, so to speak. And so, like at least in the 70s, 80s, 90s. Now we're moving to AI. Do you think that there's going to be some like, okay, yeah, we got AGI, but still, to have any sort of correctness, we still need to go back to like, how do I get precise results from database management systems?
Right. Well, I mean, look, it's probably wrong to talk about precision and intelligence in the same breath, because intelligence and thinking and cognition are all these vague kinds of notions. If you want to use an AI system to tell you, to compute the trajectories of missiles, yeah, you want them to be really precise. You probably don't want a neural network to be doing the work. But if you wanted to interpret, X-rays and decide whether an X-ray is showing some kind of cancerous growth, you want it to be at least as precise as a human, maybe slightly more precise, but you got to expect that it may not be perfect, right?
Yeah.
Because it's categorizing things, and we don't really know how it's categorizing things, and its method of categorization may be slightly off. So you've got to not simply accept the result, but try to confirm the result from your own knowledge. Obviously, if you're stuck on a desert island with an AI medical device and you have no other, you're going to have to accept its results because you have nothing
Yeah,
to
yeah.
go by. But in a hospital setting, you probably would. So yeah, there's always going to be a place for precision and for pure symbolic mathematical, computing of that kind, for the kinds of mathematical problems where you do want precision. I want to just modify something you said before. I
Mhm.
don't think precision was the main motivation back when for taking calculation away from humans and getting computers to do it. If you go back to the days of Babbage in the 1800s, and
Mhm.
even further to the economist Adam Smith in the 1700s, what they were concerned with was trying to get rid of drudgery,
Yeah, the boring work.
of boring work,
Yeah.
and the work that you could get a stupid person to do, because what you were asking them to do was so simple that even a stupid person
Oh,
could do it. Well, computers in that sense are the most stupid people there are. They can only say yes or no. And if you get enough yeses or no put together in the right way, they can do amazing things. Um, and that was one of the prime motivations. It was not so much to get better results, but to make better use of people's time by having the boring stuff done by a machine.
yeah. Yeah. That makes perfect sense. Yep. Um, I'd like to go past the LLM paper. Just I would like to go maybe a little bit to one more question and then some questions from the audience. So the first one is about some work from Walter-Sinnott Armstrong that I said earlier that a bunch of things you said um, seem to be related to that. So I would like to ask that. So he's a philosopher and he's working with if I remember correctly, with a data scientist and a computer scientist, and they're trying to create AI that is helping in moral decision making. So the idea and the specific thing they're making is you have, for example, a single transplant, and I don't know, 10 compatible people, and you have to decide where you're going to give it, and that's a moral decision, and that you're going to have AI help you with that. Now, of course, you can already do that, right? Like you can go to ChatGPT, here are the people characteristics, whatever. What do I do? But their idea is that they want to have an AI that will tell you which features it used in making a decision. So, for
Mhm.
example, it will tell you that among these 10 people, this person is the youngest. And I consider age a very important feature, and that's why I think you should give it to that person. And the idea here is, I guess, A, to have more interpretable AI, even though we don't necessarily know how exactly it got the decision, right? Like still we don't, it may still be a neural network, but it is highlighting some features. And yeah, so it will be one more interpretable in some sense. And maybe it can help us like double check our own decisions or check our biases. So what do you think about this kind of work? Does it sound promising to you?
Okay, so let's see. I don't believe for a minute that an LLM like ChatGPT, all by itself, do it with nothing but its LLM algorithms underlying it, is going to be able to make a reasonable decision like that. or even explain why. Because all it's really doing is super autocomplete. So there's no reason to trust its explanation for a decision that it outputs. Lance Fortnow, who's a computer theoretician, was using ChatGPT. I forget the exact example. It's in my paper, I think. And he was wondering why it used a feminine, why it assumed that somebody's name was feminine. And he asked it, why did you assume that? And it gave a reason, because there was a feminine pronoun that was used. That's not why it used it, I don't think.
Okay.
It used it because the statistical algorithm said the next most likely word to use in this sentence is female.
Right.
It wasn't necessarily because and only because it was thinking, oh, because he used this feminine pronoun to refer to this person. I mean, that might have had something to do with the underlying super autocomplete algorithm, but it wasn't consciously thinking that. If you ask some advanced LLM to help you make that kind of a moral decision, it's got to have somewhere in its underlying set of algorithms a decision-making procedure, not just a procedure that's going to generate the next term in a sentence. And if it has that, then yes, it should be able to say, well, I made this decision because of this particular decision-making algorithm, which had me do things in a certain way. And it will use its super autocomplete language generation system to produce that explanation in perfect English. But it's not the language generation system that has either made the decision or explained it. It's this underlying decision-making algorithm, which is probably going to be a symbolic algorithm of some kind that's making the decision. I'm not familiar with their work, so I don't know, what their computer programs are like. But those are the questions I would want to ask them.
That makes sense. And again, I am really sorry to these folks if maybe they're designing something that doesn't have a neural network, right? So maybe I am unfair too. But I guess I just want to ask on this hypothesis, what if it gives you an explanation? It doesn't matter how it produced it. Like maybe, not maybe, it
Right.
will be statistical prediction. But then you see the explanation, you're like, yeah, that explanation makes sense. And yeah, age is actually probably the most important feature here.
So look, suppose it even generates it just completely by super autocomplete. Suppose there isn't any real decision-making algorithm underlying it. If it says something that makes you think about the issue in a way that maybe you hadn't thought before, that's good.
Yeah.
You're not accepting its answer as, okay, that's the truth. That's what we're going to do. We're going to, give the kidney to this guy and not to this guy because of what the computer said. But that's an interesting point that it made. And yes, I hadn't thought about it that way. I think also in my paper, I give this wonderful example. Years ago, early 1982, maybe, I was playing with the ELIZA program. Are you familiar with the ELIZA program?
No, I don't think I've heard of that.
ELIZA was a chat program that allegedly simulated a psychotherapist who used what's called Rogerian psychotherapy. In Rogerian psychotherapy, you don't tell the patient, the client, anything. You let them talk, and you might ask a few questions, or you might repeat what they would say. Joseph Weizenbaum, who was a computer scientist at MIT, wrote a program which he called ELIZA that simulated a Rogerian psychotherapist. You would type in, "My mother hates me," and it would type back, "Why do you think your mother hates you?" Right? I think my mother hates me because I'm not beautiful. Do you think you're not beautiful? In other words, it was just echoing back. It wasn't really any kind of psychological advice or anything. People would get completely impressed by this and think that it was really psychoanalyzing. There used to be a computer museum in Boston that had an ELIZA program hooked up to a microphone and a speaker. And I sat down and I knew what the program was, and I started typing these things in here, and a crowd gathered around hearing me interact with this thing. And at the point where I figured I had everybody's attention, I started typing in things that I knew would screw up the program. And they all walked away and said, oh, it's just a computer program. So I was playing with ELIZA once, and I typed in lines from Shakespeare's play Hamlet.
Okay.
And then I made believe I was Hamlet just to keep the conversation going. And at one point, the ELIZA program asked me if something I had just typed was related to something I had typed at the very beginning of the interaction. And I had never thought that those things were related. I thought, wow, that was really interesting. Now, it wasn't comparing anything interesting. It was just saying, oh, here's something. I'll just put these two things together. But it put them together in a way that I had not put them together. And that made me think about the significance of it.
Okay.
I didn't realize it was significant, didn't even know what significance is. But so the same thing can happen with this moral decision-making program. It might give you some result by whatever, maybe just super autocomplete method, but if it makes you think about the issue, then it's doing something that may be useful.
Interesting. Pretty cool. I'll look this up. Yeah, I think that makes sense. Okay, so I'd like to move to some questions from the audience. So it's this is all under a section on humanism and transhumanism, which I wasn't sure if I should bring up, but it seems that most questions are like most questions we got were very much in tune with that. So let's see. I'm really afraid I'm going to have time to ask all the questions that I have here. So let's do this. Okay. So Rainstar's Basilisk. I'm not sure if I'm pronouncing this correctly. I'm guessing it's a name. It's in lowercase. So excuse me to whoever asked that. Oh, by the way, this is from Smurf Berries. Rainstar's Basilisks posits that enhanced agentic capability, i.e. agency, is the ultimate goal of all evolution at all scales. And one of the stages of this process is reproduction. It is therefore inevitable that as we continue to advance, not only will AGI emerge, but it will eventually obtain independence and a self-proliferating form. And this form will assuredly eclipse humanity in diversity of motivations and experiences, rendering us an initial captive audience and eventually a vestigial predecessor species. It gets better.
Well,
Do you
that's
think
the singularity.
it gets better? Do you think your opinions and work will become irrelevant in that era and preserved by future generations as if they were primitive cave drawings?
Maybe, that's possible. So look, this is the issue about what's called the singularity. That there will come a point where AGI will exist and computers will just kind of take off from there. I don't know if that will ever happen. I can't rule it out. I was once asked to comment on a paper about singularity, and my comment was basically, look, if the AGI that's super intelligent and that's so well beyond us can talk, we should be able to talk to it and reason with it. Given the current state of politics, I'm not sure that talking and reasoning is always going to be successful, but one can try. Look, right now, I think all of that is science fiction speculation. It's always worth thinking about, though, because it's better to think about these things now than to wait until it happens and it's too late. I don't know if it's ever going to happen. I don't know if it's going to happen. If it is going to happen, I don't know if it's going to be happen tomorrow or 100 years from now. Let's think about it. I have no special thoughts about it one way or the other.
Okay.
We think that the cave paintings are miraculous and beautiful works of art. So if my papers just become nothing but cave paintings, I'll be happy.
That's fair. But when I say, while you were saying that about singularity, I don't remember where I heard that, but someone was saying that singularity is near is sort of similar to saying Lisp is gonna take over the world soon. It's this thing that has been said since the 1980s.
Well, no, the story is also told about Fortran, that when future programming languages are made, no matter how object-oriented or neural network they are, they'll be called Fortran.
Yeah. Okay. Okay. I think this also is a nice one. So this is from, again, sorry to everyone out there, I'm going to butcher your names. So this is from Jan or Jan Berge. Large language models can already replace an intern or other inexperienced human for menial tasks like producing M&A decks, sorry, I don't know what that is, or writing crude apps. I am concerned that this will rob juniors from valuable experience. How do you propose the industry replace these, learning opportunities? In particular, how will they learn to review products from LLMs for quality when they haven't produced a quality product themselves?
Yeah, that's a major problem. You've got to do things on your own to learn something. We saw this same problem many years ago when the first electronic calculators came out, electronic adding machines. Because people said, why do we have to teach arithmetic? Because we can get the computer to do it. We can get the calculator to do it. And yeah, I mean, when I want to add a bunch of numbers, I go to my calculator. I can sit down and do it, and sometimes I will. But if you never learn how to do it yourself, you're not going to learn how to do more complicated things. You can use it as a crutch. You can use it as a step on a ladder. But you're never really going to fully understand what's going on. Look, the same thing happens with teaching computer programming. Today, the first computer programming course is usually in some very high level object-oriented language. When I first learned computer programming, it was machine language.
Yeah.
I've always felt that learning machine language, or at least assembly language, was better because you really got to see what was going on under the hood. And then you learn BASIC, and then you learn Pascal, and then you learn object-oriented, whatever, and then you learn Java. But without knowing the nitty-gritty details, I don't think you really fully understand things. And that's a general problem. By the way, there's a wonderful short story by Isaac Asimov, the great science fiction writer, about the future when everything is done by computer. And there's this one guy who has this really weird hobby of doing arithmetic with pencil and paper. Nobody understands why he wants to do this when you've got calculators and computers. And then, the war comes and the computers break down, and he's the only one who can solve all these mathematical problems because he's the only one who knows how to do it with pencil and paper.
Yeah, that makes sense. And I love assembly, as probably people who've read my articles know. Okay, so for the end, I'll move to some light questions and dilemmas. So one, I think I should. This is again from the audience, unknown. No questions. So this is now really a question. No questions. Long time UB, I guess University of Buffalo staff member Just wanted to tell you that your restaurant review website was an absolute gem. I consulted it regularly and remember it fondly to this day.
Thank you. Thank you. Yeah. Well, I ran a conference, it was a computer science conference at UB, and put together a 2-page handout of restaurants it was an international conference for people to go to. And every year I did a little revision. And then in 1993, the internet came along, and our staff at the computer science department put the restaurant guide on the web, and it just blew up from there. And yeah, for about 10 years, I ran this Buffalo restaurant guide. When I moved out of Buffalo, I stopped it, but people could remember it finally. It's still online. If you go to my homepage, you can find a link to it.
That's nice. All right. So I guess, well, I'm not sure if this is the light question. If it's not, we can skip it. So this again from the audience, unknown again. Based on your philosophical stance, have you invested on any AI companies? And does your philosophical thinking affect your investment? Sorry. If no, why not? If yes, why did you invest in those companies? Now, I just want to say here as a host, we don't expect you to share like your portfolio publicly, but
Well,
maybe
there's a
you.
simple answer. I do not do my investing myself. I have a financial advisor who does all the investing. They'll
Okay.
occasionally ask me questions about, do you want to invest in this company or that company? But so far, none of them have asked me about any AI companies. So I don't think I even have anything in those companies.
Well, does this person have a philosophical stance and that impact where your investments go?
I mean, look, I think that it's reasonable to plan some investing based on intentional stances. I basically would not want to invest in a company that, well, I'll be honest, I don't want to invest in a company that makes guns. Okay,
Yeah,
I don't want to
yeah.
invest in a company that does something that I'm morally opposed to.
Mm.
But other than that, I leave the investing decisions to my financial advisors.
The last light questions, the last light question, the 3 books that have influenced you the most, any genre.
That's a hard one. But influenced me for what reasons? I mean, influenced me professionally or
You can choose, I guess, change your outlook in life in one way or another.
well, let's talk about philosophy and computer things. I mean, one book that I would highly recommend to anybody in the computer world is Joseph Weissenberg's Joseph. I'm blocking on his name. The guy who did ELIZA. Blocking on his name. That's what happens when I give a talk without notes in front of me. His book, Human Power and Computer Reason and Human Power, Human Reason and Computer Power. Very, very good book, thoughtful, explains the notion of Turing machine using toilet paper and rocks, and gives a lot of good ethical issues. So I strongly recommend that. I put, rather than one single book, almost anything by Daniel Dennett, the philosopher, I would recommend. From Bach to Bacteria is one that comes to mind. That's a really, really good book.
I just ordered Consciousness Explained. So
and okay, yeah, so that's another good one. So I want a third book. Lord of the Rings, my favorite novel of all time.
Nice. Okay. Haven't read it, unfortunately.
Oh, you got to read it. It's wonderful.
I'm really, unfortunately, not very much into science fiction.
It's not science fiction, it's fantasy.
Yeah, well, okay. Oh my God, they're gonna cook me in the comments, and rightly so. I guess fantasy and science fiction are not my favorite. But I think I should read it because everyone says it's an absolute masterpiece. Okay, so now we go to dilemmas. So the idea here is you have to choose one or the other. Or well, some have 3 options. You have to choose an option. No questions asked. Okay, just tell us which one you would prefer. Now, I think the difficult part some of this is you have to choose one.
Okay.
Okay, you can't choose both and you can't choose neither.
Okay.
All right, we play?
Yep.
Okay. First, which name do you prefer? Computer science or informatics?
Computer science.
All right. Second, which field do you prefer? Computer science or philosophy?
I can't answer yes. I'll say philosophy.
Okay.
That's
Third,
what I love.
would you prefer to be able to upload your consciousness to the cloud and have direct access to the capabilities of machines, like, search the internet immediately, blah, 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 or develop superhuman abilities in the physical world?
I guess I'll go with the former.
Okay.
Uploading.
Sounds good. Okay.
Sounds less damaging to me personally.
Okay, fair. I hadn't considered. I mean, I guess this is the standard dilemma of like the two philosophical schools of thought. I always forget. I always remember them in Greek, not in English. I think it's posthumanism and transhumanism. Anyway, okay. Fourth, Chopin or Bach?
Oh, Bach, no question.
Okay. Fifth, Turing or Church?
Turing.
Okay.
I've
Sixth.
met Church, by the way. He
What?
gave a talk at Buffalo. And he was a
Oh
very
my.
interesting guy. But even more important than having met him, when I was a graduate student, I was the copy editor for a philosophy journal, Nous, N-O-U-S.
Okay.
And Church had a paper in Nous, so I had to copy edit his paper. His manuscript was handwritten.
Oh my God.
He used two different pens. He used a regular pen for most of it, but a marker for words that were boldface.
Okay.
And when I sent him the marked up manuscript, he was not happy with the size of the tilde that was used as a negation sign and cut one out of a piece of paper and glued it to his returned manuscript.
Okay.
And when he gave his talk at Buffalo, he hand wrote the talk on the blackboard.
Wait, you mean the whole talk?
He wrote out full sentences on the blackboard. I don't think he wrote out the whole thing, but he wrote out full sentences on the blackboard in this very childlike, very clear handwriting.
Interesting. Okay. Church was a character.
Yes.
Okay. Sixth, Kant or Nietzsche?
Oh, Kant.
Okay.
Definitely.
Seventh, if you could travel in time, would you go to ancient Greece or 200 years into the future?
Well, since I'm going to Greece in a couple of weeks.
Oh, I'm
I
from
don't have,
Greece, if you want any advice, let me know.
okay. I guess I would go to ancient Greece.
Okay.
I'd like to meet either Socrates or Plato or Aristotle.
Fair. You don't know what's coming in the future, right?
Right. Yeah. I don't know where I'd land 200 years from now. Might not like it.
Okay. Eighth, if you could choose an ability, would it be to speak any language you want or taste remotely? And what I mean by that is like you watch something on TV, someone's making something, and you can just taste it.
I'd
But
go with
just
the language.
okay.
Yeah.
Makes sense. Ninth, there's a committee appointed to decide the future of our environment. Who is in this committee? A, super intelligent humans, or B, conventionally intelligent humans under John Rawls's veil of ignorance?
Hmm. That's a hard one. I'm going to go with super intelligent humans as long as they're human and not computers.
Interesting. Okay. Number 10. You're about to get food delivered from a restaurant whose menu you don't know. Whoever goes there to get food for you will have to decide based on A, ChatGPT, meaning, asking it for advice, B, an algorithm you have 10 minutes to write, or C, someone who will choose randomly.
Well, I'm not sure I see a difference between A and C, ChatGPT and random choice. I think I would go with random choice.
Interesting. Okay. I just want to say I've run some of these through some other people. I think you're the first who chooses C.
Really?
A lot of people were pretty confident in their ability to write the algorithm in 10 minutes. I'm
Oh,
not.
I know I couldn't write the algorithm in 10 minutes.
Yes,
I haven't done real computer programming in a very long time. So
okay, number 11th and last one. Who would you choose to spend an hour with? John von Neumann or a super intelligent AI system?
there's a difference. I would go with von Neumann.
Okay, makes sense. I think I would do that too. All right, well, that was it. Thank you very much, William, for being here today. I had a blast. Hopefully you had
I did.
one
This was
too.
a lot of fun. You asked a lot of good questions. We had a good discussion, and yeah, it was good.
Thank you very much. Okay. I'll let you know when this gets uploaded. Of course, folks, you can add your comments down in the YouTube comments and wherever else this gets uploaded. All right. I guess we'll also add some of your contact information, well, your website, so that people can reach you if they
Yeah,
want.
sure, absolutely.
And
Yeah,
the links to
questions.
everything that was referred.
Happy
Yeah.
happy to try to respond. Probably contacting me directly is better than going through YouTube comments, but
Yes. Right. Makes sense.
so,
Okay. All right. Thank you very much. Have a great
thanks.
rest of your
Nice
day.
meeting you. Thank you for this opportunity. Appreciate it.
Same here. Thank you. Thank you for being here.
Bye.
Bye-bye.